Alberta sits over one of the largest recoverable oil patches in the world, second only to Saudi Arabia. Covering 149,000 square kilometers, an area larger than England, it holds at least 175 billion barrels of crude bitumen, found beneath boreal forest, muskeg, and rivers. To access the sandy tar-like substance, the land referred to by the industry as overburden is removed and saved for future reclamations. Cranes and 400-ton trucks haul the bitumen off to extraction plants where, in order to separate the sand from the bitumen, it is mixed with large amounts of fresh water heated by natural gas. It is then spun with a chemical solvent to further remove clay and minerals, leaving the remaining wastewater to be dumped into enormous toxic tailings ponds. The siphoned-off bitumen is then sent into pipelines to be processed into crude oil throughout North America.
C.1 A useful energy source releases energy at a reasonable rate and produces minimal pollution, while renewable energy sources are naturally replenished and non-renewable energy sources are finite. So before we get into this, we really should try to understand what energy is, and that's really the ability to do work, essentially to be able to move things. If you don't have energy, you can't do work. So there's something called the conservation of energy. Energy cannot be created nor destroyed. And we can visualize that with the idea that we're always converting energy. For example, our coal or fossil fuels have chemical energy in them. When we burn them, the bonds can actually release energy, and we can convert that to electricity or electrical energy, or we could have, like our gasoline in our vehicles, converting that to kinetic energy. These are all conversions. Now, along the way, these conversions also release something that we don't want. So, for example, if we convert electrical energy to light energy, like with a light bulb, if you hold your hand around the light bulb, you also feel some heat. Well, that heat isn't actually going to be useful to us. We can't really do anything. It's kind of an unusable byproduct. So that's a problem where our quality of energy is being degraded. So of course the energy in and energy out is always the same. It cannot be created or destroyed, but we're losing energy to the environment. It's no longer available for us to do work like that heat from the light bulb. So what we really need are energy sources that are affordable, plentiful, readily accessible, and provide high quality energy at a suitable rate. So high quality energy at a suitable rate, that essentially means that it's not such a dilute energy source that it would be impossible to sort of collect enough of it that would meet our demand. And so not too fast, not too slow is another part of this. So if we were to try and think, okay, well, something that creates a lot of energy is like an atomic bomb. Well, yes, of course it releases a massive amount of energy, but it releases it far too quickly to be useful. It's more destructive than anything. So an atomic bomb would not be a good energy source. And we want to make sure that we're also reducing the number of pollutants as well as the greenhouse gas emissions that are produced during that. So let's take a look at some energy sources and look at if they're giving us something at a reasonable rate, that they're renewable, and that they produce minimal pollution. Now all of these are high quality energy sources. That's a little bit overwhelming. Let's try to see if we can take a step back. All right. And we'll just highlight these, but yeah, these are all high quality, in which means we can collect enough of